Welcome to the Geobodies modeling presentation. In this video, we'll see how to create geobodies before building a relative geological time model in order to exclude noisy area. Multi-Z objects such as salt volumes or layers from horizons can be created. We'll see how to use the relative geological time model to create continuous layers and to extract geobodies directly from amplitude maps or from amplitude volumes. As described in this workflow, multi-Z objects and layers between horizons can be generated in order to prepare data, 3D model or seismic volume, to exclude noisy or salty areas. Other kinds of geobodies can be created based on the 3D model, such as layers created from relative edges and geobodies extracted from amplitude maps or directly from amplitude volume. Let's now have a look on the geobodies modeling in PaleoScan. We'll see how to pick multi-Z objects, so this task is done before creating the geomodel. So this kind of object will be used to exclude data in the seismic. Here you can see some salty area in this volume, so we can now switch to the multi-Z picking module. And we can start the picking by clicking on this new multi-Z button. After giving a name to this multi-Z object, the 3D viewer is opened in order to follow the multi-Z picking. So now the multi-Z picking mode is activated and I can start the multi-Z object picking. It's easily to do. We just have to add some picked points where we can see the salty area. Then we can continue the navigation through the volume and continue the picking where we can see the salt. Here and here and here. So we can continue the navigation, and as you can see here in this 3D view, the multi-Z picking is updated on the fly according to the picking from the 2D view. By displaying the seismic in 3D and by navigating through the seismic volume directly from 3D view, we can see the intersection between the multi-Z object and the seismic. We can now validate this multi-Z object. So yes, I want to save it in the database, so we just have to give a name and click OK. Now the multi-Z object is saved and stored in the project browser under the Geobody tab. Here. We can now go back to the multi-Z editing by using this option. Here you have to select the multi-Z object which has to be opened in 3D. So now this multi-Z object can be re-edited. And we can use options to navigate more easily in the volume by switching from picked polygons like that. It's easier to navigate in the volume according to the picked point already done. So now this multi-Z object is finished. We can validate it. So now by selecting the same name, I can override the pre-existing multi-Z object in the database. We saw how to coarsely pick a multi-Z object in this video. Now let's have a look on the multi-Z object previously picked more in detail. So by opening them in the 3D view, you can see them in intersection in the seismic. We can select the seismic and navigate through the volume to see their intersection in the seismic. And if I go back to the seismic view, the 2D view, we can navigate through the volume and see them in intersection. So now we'll see how to use these multi-Z objects as excluded zone in the seismic volume in order to prepare the seismic data to generate the model grid. So we have to switch to the attribute module and use the truncation option. So from this tool, we can select the truncation 3D and add it in the list of attribute to create by selecting the seismic and by dropping the multi-Z objects in the 3D object field. So here I can select 3 multi-Z objects and drop them in this specific field. You can see the multi-Z object in intersection in the seismic. Different methods are available, elimination or truncation. So here is the preview of the elimination. So the seismic will be excluded inside the bodies. So here with both multi-Z, you can see the effect of the elimination. And now we'll show the truncation method. And if I do preview, you can see the seismic will be kept inside the bodies. For data conditioning, we usually use the elimination method. Here is the 3D seismic volume conditioned according to the multi-Z object. So you can see data salty area has to be removed from the seismic. So let's now have a look on the layer creation based on the 3D GeoModel. To do so, we have to go in the Geobody manual module. And here is the option to create layer from GeoModel. So from this tool, we have to select a 3D model here, which will be used as input of the layer creation by using the relative geological times. Here is the best color bar to understand the GeoModel. By selecting the seismic, we have a best view to see where we have to put the boundaries of the layer. Adjusting the top and the bottom boundaries for the future layer, so we can move them in detail by using the arrows. And once the boundaries are well defined, we can launch the layer creation. We just have to give a name. Here is a layer corresponding to a sigmoid. And now the layer is saved and stored in the database under the Geobody tabulation. Once created, the layer is opened in 3D as a triangle mesh object. And we can navigate through the seismic to see the intersection between this layer and the seismic. We can also have a look in a 2D seismic view to see the intersection. And thanks to the transparency of this layer, we can see the seismic information inside the layer. So this is very useful to analyze sequences corresponding to layers. Let's have a look on the isocore computation. So I can select the layer created and select the seismic as a survey. Now I just want to display the isocore result in 3D. So by clicking on Finish, we can see the isocore map displayed in the 3D view. And we can also hide the layer from 3D in order to visualize the isocore map in 3D. By playing with the color bar, we can adjust the isocore information. Here, the blue information corresponds to a sick part of the layer. We will now see how to create geobodies directly from Horizon Stack. This object, this Horizon Stack, is directly created from the 3D GeoModel. So now we can open a RMS amplitude Horizon Stack. So here, in this kind of Horizon Stack, we can easily detect amplitude anomalies, and we will use these anomalies to extract geobodies. Now I'm navigating through the horizon stack by going up, and we can focus the geobody creation on this specific bright spot. So here is the geobody we want to create, we want to model. And we will use the color bar to isolate this body by using the color selection. Here we can play with the blue selection in order to isolate the bright spot in terms of amplitude. And I will use the polygon creation mouse mode to discriminate the geobody by creating polygons which will be used in the geobody computation. So now I'm just selecting blue parts corresponding to the future geobody here, and I'm creating polygons on each horizon where I can see this bright spot. I can pick very small polygons. Okay, so once the polygons are defined, we can remove the color selection in order to have a best view on the polygons, and we can now validate the bodies. So now PaleoScan will use the polygons to create the geobody in 3D as a triangle meshed object. So you can see here in 3D this geobody, and by navigating through the seismic, we can see the intersection between the body and the seismic information directly in 3D. And we can also see this intersection in the 2D view. Now we can select this body in order to generate or estimate the volumetrics of this body. We have several units to select. We can use barrel or acre-foot barrel, for instance, and we have to define a factor for the relationship between the time and the depth domain, and a message appear showing the volume estimated. Now let's have a look on the attribute mapping on 3D object. So we have to select the bodies, select the seismic to use for the attribute mapping, and we will map the information on the top of the body. Now let's select the filter. So we have a long list of filters to compute. We can now generate the RMS amplitude. A window size is needed to generate the RMS amplitude, but we will use the geobody itself as dynamic window size to compute the RMS information. We can display the map in 3D and click on Finish. Now PaleoScan is computing the map corresponding to the RMS amplitude attribute on the top of this body. By hiding the body, we can see the RMS information directly in 3D. And we can also play with the color bar to adjust the contrast in order to see where are the highest value of the RMS information. So we saw the semi-automatic geobody extraction from horizon stack based on the amplitude values selection. Now let's have a look on the manual geobody picking. We can navigate through the horizon stack by going down, and here are some very small channels that you can see from the RMS amplitude information. So we will focus the picking on these channels, very thin channels. We can see them on this map, but also by using the cross navigation mode, we can see this event in the seismic. And as you can see, this is a very, very small event in the seismic information. So to manually pick the geobody, we will use the brush. And from the properties of the horizon stack, where we have to select the horizon stack viewer, we can control the size of the brush. So I'm just decreasing the size, and now I can start the manual picking. So I just have to move the brush along the channel I can see on this horizon. So I can also play with the zoom to adjust the size of the brush. By zooming in, the brush is smaller, so it's easier to follow the channel. Now I can change the horizon, I can change the display of the horizon stack. So I can follow the event on a new horizon of the stack. The aim is to pick the body where I can see it on different horizons. So the picking is the same compared to the semi-automatic extraction. We just have to create geobody polygons in order to isolate the body, the future body. And when the picking is done, like that, we can validate and create the geobody in 3D by using this button. I can save and display this future geobody, give a name, and click OK. Now the channel is represented by this body, and you can see its intersection in the 2D view, here in pink. And by scrolling through the horizon stack, we can see the body in map view. Of course, we can also see the channel created as geobody in the 3D view, and we can analyze the intersection with the seismic directly from the 3D viewer. We can now go back to the horizon stack viewer in order to display it in 3D, to combine all the information related to this channel for a good view to analyze it. So we can see it in map view and in intersection with the seismic. So now we'll see the last tool to create geobody, which is the automatic extraction directly from amplitude volumes. We have to activate the advanced interpretation extension to go to the sequence stratigraphy module. Here we can open that we call a stratigraphic viewer. I have to select the 3D model which will be used as input of this view. And we can now select an attribute for the automatic extraction. We will work from the RMS amplitude volume. So by dropping this data here, we can see the RMS information, and we can navigate through the volume to see the amplitude anomalies. We can also use the cross-navigation mouse mode in order to see where we will have to generate the body. So we will focus our attention on this specific bright spot here, and you can see it from the RMS amplitude information. By creating a sequence, we will be able to generate a layer containing this body. So here in the stratigraphic view, we can switch to the sequence picking, and based on the 3D model which is in the background of this view, we are able to define a specific interval based on the relative geological ages, and we can isolate the body, or let's say the amplitude anomalies, inside this specific layer. We will use the color selection to isolate the RMS values corresponding to the future geobody. So it appears in blue, and by selecting the layer, we can use this option here to build the geobody corresponding to the blue selection. So I can give a name, and by clicking on OK, PaleoScan is creating all the bodies corresponding to the blue selection inside the entire layer. So you can see now, by hiding the sequence, we can see the body in intersection with the stratigraphic view. And if we display the 3D viewer, we can see the result here in 3D. So as you can see, the generated body appears in pink here, and we have different pieces of body corresponding to different events. So we have several bright spots. We have to split this body to different pieces in order to isolate the specific bright spot we want to model. So we can play with this 3D view corresponding to the geobody splitting. So by playing with the sliders, we can discriminate geobodies according to their size. So here we can keep only these bodies. Okay, so now PaleoScan split all the pieces as single geobodies. And by using the selection mouse mode right now, we can select this body and save it as an independent geobody. So we can give a name and save it. And we can also save this geobody. And all these bodies are now saved and stored in the project browser under the Geobody tab. So now we can hide all the bodies that we don't want to keep. And here you can see, yes, the 3 geobodies saved in the database. We can now display all the bodies we generated and the horizon stack used for this geobody creation. And by moving the seismic, we can see the intersection between all these bodies and the seismic information. To conclude this video, we saw how to create geobodies before and after the relative geological time model creation with manual, semi-automatic, and automatic extraction tools. Thank you for your attention. You can see more videos on our website, on our YouTube channel.